When they see me, I write on the whiteboard. So how to show me? How they can see me? My voice. Do I have some microphone? Okay, okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning.
Morning,
Are you
doctor.
hearing me?
Morning, doctor.
Morning, doctor.
Okay. So now here 100% students in the class, right? 0 students. But this is now our teaching class is quite okay. I can see that. Can you see my lecture notes?
Yes,
Can you
doctor.
see?
Yes.
Okay. What about me? If I write on the whiteboard, okay, for example, y equal to f of x. Can you see?
Doctor, the whiteboard is too far from the camera.
Okay, it is too far.
Okay. You can zoom. This one. Zoom camera.
Zoom camera.
You comment this.
Like this. Oh, when I do like this, then zoom camera. So can you see whiteboard?
Cannot see clearly, doctor.
So they cannot see. This bring close. I think bring close. So what about? Can you see now? But still not good. You should see the whiteboard. Please bring close. Yes. Now, how can you see? So whiteboard is okay, huh? Now, if you see me and especially the whiteboard, if I write in 2 ways, x belong to capital A. Oh, this one not good. Oh, okay, now 58 students. So can you see me and whiteboard?
Yes, doctor.
Yes, doctor.
And doctor.
Okay, huh? Now clearly seen, huh? Maybe light, more light.
Yes, clear.
Clear, huh? Okay, good. Okay, in that case, let me start. So I think just a little the lights, little bit more. So now, no waiting. Everybody is here. No in the waiting. This. I see admit. Please be another 5 minutes, okay? Because students still. So can you see me there? And whiteboard there?
Yes.
Yes.
Okay, now everything is okay. So far 58 students. Okay, I think the if we're waiting, actually some students will sometimes will be late. Okay, in that case I will make it. Okay, thank you very much for your help. Now let me start, okay? Okay, thank you. So admit one more. So okay, anyway. So thank you very much. Now let me a little revise in the previous class. Actually, in real analysis, we give the definition of the function a bit different than the okay, one moment. So my voice is also okay, huh? You can clearly listen my voice, right?
Yes,
At least
doctor.
from the next week, you try to come to the class. Here, you see the very nice room, auditorium is quite okay. And who are living inside the campus, it's better to come, okay? So, please pay attention. There are actually two important definition, okay? Two important definition. One, how to find the f of a, okay? So by the definition, it is said f of a is a set of all x, right? F of x, because f of a is an element of b such that x belongs to the a. Imagine, so we have a, which is called a domain of function, and we have b. So usually in the standard way of explanation of the function is that every element of a has x1, x2, and for example, xn. So f is actually a rule, right? Assign us for each element of a, one element in the b. So y2 and etc. This is yn. So this f is a rule. Now, you see, f of a, actually f of a is an element of b. You see, element of b. So that's why we put f of x, where x derives from a. So for every element of a, by rule, we will get the aside the Y. We call it an image. This one call it image. And there is a pre-image. So please here pay attention to important things. This is A, this is B. Now, I will take element from B and with inverse, I will get the element of A, x1, x2, and etc. xn. You see, f minus 1, f minus 1, and f minus 1. So, when f minus 1 means it is acting on the element of the B, and we will get, look, f minus 1 B is a set of X, is a set of X, by the definition, is a set of X from the actually all element from X, from A such that f of X belong to the B, belong to the B. Or another definition says it is the element of X from A such that f of X equal to B. Okay, either one you can use it. But here, important point is that if we get the mapping on A, which is this is some kind of set, and this set will be subset of B. Subset of B. So some people asking. Okay, one moment. Please, next time you should come. This is taking some time. Please, next time come on time. Otherwise, I will lose a lot of time. So, please pay attention again. So, f of A is a subset of B. Okay, but this one, we cannot say is a subset of A. So, another word, okay, imagine, so this is the, let's say some subset of B, okay, and we are mapping element of B into A. So, in that case, if we have all the inverse element of Y, it may not be the subset of A. Okay, it may be maybe some element is out. So that's why we can here there is no inclusion. There is no inclusion. Okay, but for the f of A we have inclusion. So that's why now the next preposition we can prove. Okay, next preposition. How we prove the next preposition? Okay, this is the imagination. For imagination, everything is okay. Now, in order to prove that, I need the space. The first one, I need this definition. Okay, that definition I will put on the top and do proof because this one I need. F of A is the set of all f of x such that x belong to A. And on total, it is a set of subset of B. Okay, that's definition. So from that definition, now I can prove don't have any good one. Another problem. Okay. Now look, preposition says let f maps x to y. Actually, now x and y, actually the largest set. X is a domain, y is a codomain with a function from x to y. Suppose that A is a subset of x and B is a subset of y. So please pay attention. A is a subset of x and B is a subset of y. And f of x, this is the definition of f of A. So then it is said that the I one, the first one. I says f of A, actually A is a subset of f minus 1 of the A is a subset of f minus 1 of f of A. Okay, I want to prove. There is no proof there. So this one means, look, now this one is a capital X. This is a capital X. And this is a subset. This is a subset. So it is said, if we define, look, here, f of A, actually, f of A, by the definition, it is this, and I can say, so this is the another, let's say, I can say another set C, okay? Set C. So now I will put here this C, f minus 1, minus 1 of C. C is a set of all elements of f of x such that x varies from A. So by the definition of f minus 1, f minus 1 C, it is the element of all x such that, by definition, all of f of x, all x from C, such that f of x is the element of C, and is the element of now the f of C is a C. Yes, it is correct. C. Okay. By the definition, the E actually this one is the element not of actually f of A is all the element of here A. This one is A. It is the element of all element of x from A such that f of x is the element of C. Okay, this is the definition. So if you look at the right side, what is this set? Okay, now look, if f of A has element, so this is all this element is a C, capital C, and this one is Y, capital Y, actually it is not C, it's better say B, okay, because over there A and B is a subset. So B is a subset of Y. So we collect all the element of f of x from B such that the x belong to the A. Okay? From the first definition. From the second definition, Now, when we are acting, so this one becomes B, and this one becomes B, and this one becomes B. This is a B, and this is a B, and this is a B. Okay? Please pay attention. So here, the F minus 1 E subset, it is the element of X from A. F of X is the element of B. Okay? B is a subset of this. So now, why A is a subset of this set? Huh? Because this is the element B, and it's a subset of, by the definition of these, see, by the definition of the first element, all the element of f of x from x to the A is a subset of y. This one is a subset of y. Okay, subset of y by the definition. But for the inverse, we don't have subset of A, because you know this inverse actually inverse the having the element of all x from A such that f of x belong to the B. Okay, so the now the A belong to this set.
Doctor,
Yes.
sorry to interrupt, Doctor. Doctor haven't record, is it?
Oh, yeah. One moment. I haven't. Subject of A and the set which is subset of B. See, this one is a subset of B.
Doctor, your voice is not clear.
Okay, so let me explain that. Okay. Now the B subset of Y, and it is not subset of A. Okay. Actually, I just use the definition. Now look, this one is a subset of Y. But when we add the F minus 1 to B, which is this set, is not subset of is not subset of A. You see, this one is not subset of A. So it means it contains A. Okay. So just by using definition, we can say by definition, this set doesn't contain in A. It's not contained in A. Okay, that's the proof of the first one. The second one, in the second one, we use again. So for the second one, definition. So it is say f of f minus 1, f of f minus 1 B B is a subset of B. Is a subset of B. You see, here again, what does it mean F minus 1B? By definition, it is a set of X from A. A is a subset of capital X such that F of X is the element of B. Okay, it is element of B. But this set, this set is not subset of B. Okay, it's not. It is not subset of A. It is not subset of A. But we call it this one. It is not subset of A, but let's say it is some set C, which is not subset of B of A. Okay, because this is the element of A according to this. So now, if I take f of C, it is the element of all function f of x, such that x belong to A, right? Okay, let me see again the definition. F minus 1 of E, it is the element f of C. So it is all the element of f of x such that x varies in A. A is a subset of x. C is a subset of y. And by the definition, this C, it is a subset of A. It is a subset of A. You see, actually, no, B, because this is the element of B. F of C, it is the element of B. By the definition, it is a subset of B. You see? So actually, mainly role plays the definition. So F of A is the element of B such that it is a subset of Y. Okay? Now, if we look at this definition, F minus 1B is a set of C such that it consists of all X from A such that F of X will belong to the B. So you see, but it is not subset of A. But F of C is a subset of B by definition only. Okay, so that's why we can prove it like this. And here, good examples is given, and from here you know how we can find actually A and B is solved it there. How we solve, for example, C. Example, the C. The f of x is given as a function minus 3x plus 1, right? Minus 3x plus 1. Okay. And it is said find f of 0 infinity. So find, you see, 0 is included. Infinite is not included in the set. Okay. How we find? Actually, you can see, so this is the element of B. It is some kind of element of B because we are mapping all this interval. So how can I find the B set? You see, it's almost similar things. We will make it by the definition. So by the definition, what does it mean f of 0 infinity? By the definition, it is the element of so it is element of all f of x. So yes, it is f of x, right? F of x such that x belong to this interval, 0 to infinity interval. This is the definition. So by definition, I can write x less than from infinity greater than 0. Okay, from here I can easily get minus 3x. If I multiply by minus 3, it is greater than minus infinity and less than 0. If I add plus 1, minus infinity plus 1, less than minus 3x plus 1, and less than or equal to 1. This is still infinity, negative infinity. 3x is f of x, minus 3x plus 1 is the f of x, less than 1. So from here, I can easily can see, so the function f mapping that interval into this from minus infinity up to 1. 1 is included in the set. You see? So this function, this function actually maps this interval into that interval. Okay? So this is a finding of still somebody waiting? Okay. Please, the last one you need to solve yourself, okay? So let me go to the next. Okay. Now, how can we prove the second theorem? This is another interesting theorem. So I leave it to just definition and remove the rest. So, do you have any questions so far? Clear, huh? No questions. Okay.
So far, okay, doctor.
Okay, good. So far, okay. So please give some feedback. Otherwise, I don't know. If you are not listening well, also please. If not seeing well, also please let me know. Otherwise, I say that you are okay and nothing problem. So okay, now let me only this one. I should bring the new one actually. Okay, no problem. Next.
Doctor, can doctor move the whiteboard like in front a bit because the right side of the whiteboard is a bit not clear.
You mean
Yeah, the diagram.
diagram not clear. So in that case, this one I will move little bit back. Okay, can you see?
We can't see anything, doctor.
You can't see anything.
I couldn't see doctor also.
They say like this or something like this to make zoom. Can you see?
No, doctor.
Oh, in that case, moving actually not. Oh, it is a problem actually. Mhm. I shouldn't move. No, you cannot see.
Yeah, we cannot see.
Yeah. So I have to call them again. I don't know how to. I just little bit move and already. Come on. So this is very sensitive actually. Okay. In that case, let me call them because I should write on the whiteboard to explain. Just wait, then. Just wait.
Okay, doctor.
How to handle? Please show me. Hello? Are you hearing me?
Yes, doctor.
Can you see now? The right side also? Can you
Yes,
see?
doctor.
Yeah, Alhamdulillah. Okay, thank you. So I will continue. Yeah, actually, many students coming late. I don't know. I don't want to erode them. Okay, thank you very much. Which number? 42665. From my handphone? Okay. Okay. Okay, so much time is spent. Now let me prove the theorem. Huh? So yeah, this is very non-effective. I can't reach even one page so far. So anyway, now moving also not easy, but what to do? This is a bus. Should have better one next time. Okay, I hope you can see now. So let me prove that the actually very interesting problem I can see here. Now look, in this first theorem, it is said if f acts on the union of the set, then it is equal to f of A union f of B. The second, if f acts on the intersection of AB, then it is not equal. It is not equal actually. F of A intersection of f of B. There is one counter example. So that's why. So we can show they are not equal. Okay. Now, how to show the inclusion? Okay. So this one is a subset of that. This is second interesting phenomenon. So if I use f minus 1 acting to the A union B, so actually this is minus 1 of A and union f minus 1 B. Another interesting point, the next theorem, actually just I want to show only two cases. The rest will be, you will show yourself, f minus 1, A intersection B, then it will be equal to f minus 1 of A intersection f minus 1 B. So I'm summarizing these two theorems, 1, and 1, 2, and proving these two properties from both cases. You see, if we act a function on the union, okay, we have equal. If intersection, then we don't have, we have inclusion. So the interesting point is inverse function acting to the union of the set, it will be equal to f of minus 1 and f of minus union f of. If intersection, it is intersection. So now let me show this type of problem, how to handle. Okay, how to handle. Proof. Let me prove use this. Proof. So I just use the definition. What does it mean? F of U union B. And actually, what I do, I will take any element from the left side. So that's why actually this is the Y I'm taking from the left side and show it is the element of the right side. And Y stress is also okay. So by definition, what does it mean this? So it is the element of f of x such that x belong to A union B. So by definition, this is the definition. So I am taking any element from Y from the left side. Now, if you look at this, x belong to A union B equal either x belong to A or x belong to B by definition, right? So if x belong to the A, what about f of x? F of A, okay? Not f of x, f of A. F of A. So it is a, by definition, it is the element of y or f of x such that x belong to the A. Similarly, f of B, it is the element of all f of x such that x belong to B. Now look, I am reading. If x belong A, then f of A is the element of this set. Or if x belong to the B, it is the element of this. So actually, this is the element of Y. This is the another element of Y. You see, Y belong to f of A or f of B. From this definition, I can conclude Y belong to f of A union f of B. Okay? You see? Using, you can see x belong to the A, f of x is the element of B. Because actually, they use that way. I just use the definition, and so this is the element of A belong to the f of A. Okay, and when x belong to the B, f y belong to the f of B. So from that one, I can conclude that the y belong to f of A union f of B. Either one, either one. So why the second one is actually vice versa. So from this, I can conclude the y belong to f of A union f of B. Okay. So this is the conclusion of this by this proof. Okay. Now, if I take the element from the right side, because in order to prove, if I get element, this is the part one. The part two, if y element belong to the right side, f of A union f of B. So by definition, y belong to f of A or y belong to the f of B. So by definition, f of A is the element of f of x such that x belong to the A. this one is a function of f of x such that x belong to the b. We say either when y belong to f of a, x belong to the a, or if y belong to the f of b, f of the x belong to the b. You see, from the definition, I can make conclusion that x belong to either a or b, which is a union b. Okay. I will show it now next. So I think over there and here it is the same. Look, if y belong to this, the y belong either f of a or f of b, right? And when y belong to the f of a, according to the definition, there exists x such that there exists such that f of x equal to y. Actually, I think this one is more clear. Because when what f by definition, f of a is a set of all f of x such that x belong to the a. Here x belong to the b. You see, when y belong to the f of a, x belong to the a. Y belong to the f of b, x belong to the b. Or between them or. So that's why from this definition I can get this. Over there also correct for because f of x equal to y, f of x equal to y means actually this is the definition. Okay, so that the others you can see how they proved. So now just I want to show why the second one doesn't equal. Actually, before proving, better to see one interesting example. Okay, before proof that, I want to show that one example and very interesting and easy to understand. Okay, let x and be the set of all real numbers, okay? And the f is a mapping x to y, be a function defined by, okay? Example 1. Y is equal to x squared. So f is given like this, and a is given as minus 2, 1. Minus 2, minus 1. And b is given as 1, 2. 1, 2. So now I want to find f of okay, I want to find f of a intersection b. Okay, so first of all, intersection a and b, from here I can see it is empty set. There is no intersection. This is minus 1, this is plus 1. So it is f of empty set. When f acting to the empty set, it is the empty set. Now, I will define f of a union intersection f of b. Okay. Now, what does it mean f of a? I can easily find. So if x belong, look, if x belong to this interval from minus 2 to minus 1, in order to get the x square, what I do, I will multiply. If I, raise into the square, I will change opposite way. So x times x So since x is negative, when I multiply by x, which is x squared, and actually it is like this, from 1 to 2. So when I raise x squared, so x squared cannot be negative. So it's starting from 1 to 2. So from here, I can see f of x belong to 1 and 2. Okay, now if x varies, this is f of a. Huh? I found f of a. This is f of a. Not f of x, f of a. So f of a is this interval. What about f of b? For the f of b to find, so x varies from 1 to 2. If I raise both sides, x squared, this is still 1, this is 4. So now f of b belong to from 1 to 4. Okay, now what about f of a intersection f of b? Okay, f of a is 1, 2. 1, 2.
Doctor, isn't it f of a is 1 to 4? 1 and 4?
Yes,
Because
yes,
negative.
sorry. Raising to this 4, 1, 4. Sorry. 1, 4. Raising to the square 1, 4. Yes. It is 1, 4. Yeah. Thank you. 1, 4. This one, the 1, 4. The second one is also 1, 4. So which is 1, 4. Okay, let me see. Is correct? In the example, yeah, f of b intersection f of b, it is a 1, 4. Correct? Look, when x varies here, raising to the square gives this interval. If x varies on here, raising square both sides gives that same interval. So f of a and f of b is not empty set. It is 1, 4. F of a intersection b is empty set. So that's why now from this example we can see they cannot be equal. They cannot be equal. And inclusion is correct. It means if I take any element from the left side, it will be element of right side. If I take any element from the right side, it may not be element of the left side. Okay, that is the main idea of that proof. Now from this example, you can see inclusion is correct, but we need to prove. This is by showing the example. Now I will prove the theoretically. Then interesting point in the inverse, both of them are the same. They didn't show that one, but if possible, I will construct the one example. Okay, can I remove?
Yes, doctor.
So to show the second one, you see very interesting point. The inverse has different properties than their function f. Okay, so now the first one proof is done. So theoretically, how can I prove? I can prove the following way. So now, as I told you, that the proof of 2. Example, everything is clear. I will take the y from this intersection B. Actually, you see, to me, just memorizing the definition actually giving a lot of info for us. So f A union B. What is the set? It is a set of all f of x such that x belong to A intersection B. Okay? According to this definition, if x belong to intersection of A and B, it gives either x belong A and x belong to B. Okay? It should be belong on both. If x belong to the A, then what about f of A? F of A. According to the definition, it is a set. It is an element of f of x such that x belong to A. Actually, this one is y. F of x is y. So from here, I can see f of B is the element of all f of x such that x belong to the B. And here we have between them, there is an end. Look, y is the element of f of A. You see, this y is the element of f of A, and y, this is y, is the element of f of B. Okay. If x belong to the A and B, from here I am getting y belong to f of A and f of B. You see, from here I am getting this conclusion by the definition. So this one shows if y is the element of that side, then it is the element of that right side. Now y space is not correct. So if I take now the second part, if I take y as the element of f of A intersection f of B and f of B. So it by definition, y is the element of f of A and y is the element f of B. By definition, f of A is the element of f of x such that x belong to A. And here, and this is element of f of x such that x belong to the B. Okay, this is just I wrote it the definition. Now, how can I show if y is the element of the intersection of f A and B? Then it is not element of this. It is not element of this. Okay, so now f. Now I will just use the definition of f of A intersection B. So it is a function of f of x such that x belong to A union B. Or this is equivalent if x belong to the A, this one shows x and x belong to the B. So if x belong to the A, what about f of A? F of A is an element of y, which is f of x, such that x belong to the A. And f of B, so it is a function of f of x such that x belong to the B. Okay, what we can see from these two definitions? Okay, f of x. So I should show that if y belong to this set, then it is not belong to that, not necessary to belong to the left side. So by definition, I can't see the difference, huh? Because y is belong to the f of a or and f of b, which is intersection. Y belong on the intersection of these two sets. Here, okay, how it is there proving over there, as they say, so intersection actually is not proven over there also, but it is not proven over there. 1 and 3, they prove 1 and 3. Actually, the second one is not proven yet. It's not proven there. So now from this two definition, how can I make conclusion that y doesn't belong to this set? If y belong to this set, it not belong to this set. How can I show? So actually, this is the element of y. This is the element of y. So this is a set. You see, little bit difficult to, but in the example, of course, we have shown in the example. But in the theoretical case, so when y belong to this one should be wider set than this. Why? Because x belong on the intersection. So this intersection so y is in the element of this set, y is the element of this set. When x belong either the both sets. So can I say y belong to the can you say anything? Hey, my friend, sometimes you give good clue. Do you have any idea? Currently, because counter example already shows that inclusion is correct. But in the theoretical proof, how I can show that if y belong to this set, not belong to that this set. See, the x belong to the intersection of the b, which is this. See this, and f of a and f of b. It looks like same as this, f of x and f of y. But here, y belong to the f of a, y belong to the f of a. Here, x belong a and b. See, that's the differences. Okay, directly I can't see the inclusion, but definitely this one, because f of a and f of b, the intersection, separate intersection of two sets actually is wider than the f of a intersection b. So, but only direct conclusion I cannot make it at the moment. Okay, let me see. Maybe the next time I will, if I get the proper idea, I will show you. Otherwise, just accept that. You see here, of course, there is a difference. This set is the same set, f of a and f of b, but here x belong to the a and b. Here y belong to the f of a and f of b. That is the differences. So f of a, y belong to the f of b, and x belong to the a and b. But counterexample already shows. Okay. Now let me prove that the second theorem, y f minus 1 has no such kind of inclusion. You see, it is they are in both cases are equal. Okay. Let me show prove the second theorem. Okay. Okay. So currently direct inclusion is not seen, but I can see that by example we have seen that it is correct. Okay, now let me see the proof of the second theorem. See, in the second theorem, say that union f of minus 1. So what does it mean? This one means if actually if element x belong to f minus 1 of a union b, I'm taking the element from the left side. So by the definition, this the inverse definition says f minus 1. It is the element of x from a union b such that how we get the definition f of a like this. It is the element of x so element definition. Okay, how is it put the definition? X belong f of x yeah, f of x belong to the a union b. Yeah, this is the definition. Okay, by the definition, you see, f of x belong to the a union b. So now I'm taking this f of x belong to the union of a union b, means f of x belong to the a, or f of x belong to the b. Okay, so from the definition I can say f minus a union b, actually that's the element of x. So it is like this, correct? So either way. Now if f of x belong to the a, now from here I can say if f of x belong to the a, what does it mean? Belong to the a, then x belong to the f minus 1a. Yeah. So from here, if I find x, it is belong to f minus 1 of a, right? F minus 1 of a. Yes, correct. So I'm acting f minus 1, you know? So if f minus 1 becomes x, f minus 1 of a. Or here, x belong to f minus 1 of b. See, from this definition, I find out x belong either f minus 1 of a or f minus 1b. You see, either or. From here, I can make conclusion x belong to f minus 1 a union f minus 1 b. See, I'm taking any element from the left side and reach, it is the element on the right side. Converse, conversely, if I take element from this is the first part. Now second part. Second part. I am taking the x element from right side. F minus 1 of A union F minus 1 of B. So it shows x belong to F minus 1 of A, or x belong to F minus 1 B. Correct? By definition, x belong to the F minus 1 of A, and or F x belong to the F minus 1 B. By definition, F minus 1 of A, it is the element of x such that F of x belong to A. It is the element of x by the inverse sign, element of x sorry, is it correct? F of x cannot belong to the A. Actually, f of x belong to, because if A and B is the domain of f function, x from A such that f of x belong to the B, So, okay, let me properly check, because so this is actually handling our problem. So the number 3, did they solve? Okay, let me see. Second one is already there. So please look at the proof of the second. The first part we have proved x, hence x belong to the f minus 1 or x minus b implies this. Now I am taking the left side, f minus 1 a and f minus 1. F minus, this is correct. Thus, f of x belong to A and f of x belong to B. By definition, so here this one A, this one A, and this one B. So please, this one B, this one okay. Over there, they easily just say f of x belong to the A. F of x belong to the A, and f of x belong to the B. But we should use the definition. Definition says, let me see here. Definition. See, actually, definition of, look, f of here E. Actually, E is a subset of B. B is a codomain. Okay, codomain. F of E, f of f minus 1 of E is a set of x from A such that f of x belong to E. So this is the definition of inverse function. Okay, definition of inverse function is like this. Now I have to use this definition for this case. If x belong to the f minus 1 of A, Now here, please pay attention. Actually, A is not the domain of. Please pay attention. Here, A is not domain of function f. Actually, it is a range, the one part of the range. Okay, so that's why, according to this definition, so x, the f of x belong to the A is correct. So it is the element of x, but where is the domain? Where is the domain? See here, f minus 1, this is the definition. So it is belong to the, so it is x belong by definition, f minus 1 a plus b, meaning it is all the element of x, f of x. No. So this way application is not proper. Okay, this type of application is not proper because here actually here A is a domain of x, so therefore x derives from A, such that all f of x belong to the E. This is proper definition. Now, if I apply to this, so x belong to capital X, such that f of x belong to the A. Okay, we should find all the element of f of x belong to the A, such that the x is the element of capital X. So here also capital X, f of x belong to the B. I think this one is better correct definition. Okay, and here so function cannot be, x cannot belong to this. X belong to capital X, such that f of x belong to this. Okay, then f of x belong to this by definition. It is belong to the A, belong to the B. By inverting, this is correct. This proof is correct. Here, okay. Now what I do? Okay, I do like this. Just I will apply the inverse. From here, I will apply inverse of f. If I apply the inverse means f. So f of x belong to A. If I apply, for this, or f of x belong to the B. Am I right? This is or. Okay. This is y. Actually, f of x is a y. From here, I can see y belong to A union B, right? So f of x, from this I define this. Now f of x, y belong to A union B. What does it mean? Okay, this is correct, but I want to prove that if I take from the left side, from the right side, the element x, I want to show it is the element of left side. Okay, now from here I come to this is correct. Now from here, y belong to the no, I want to show that x belong to the element of that area, that area. Okay. So over there, how they say? So f of x belong to the A, f of x belong to the B. That f of x belong to the both A and B. F of x belong A. Which one I am proving actually? The second one, right? Yeah, I am proving the first one. F of x belong to the A. So f of x belong to the set A and B. Then okay, correct. F of x. This is f of x, correct? F of x belong to the A. So from here, I can say like this, and which implies x. Oh, okay. After this, I apply the inverse. When I apply the inverse, on the left side, I will get f belong to f minus 1 of A union B. Okay. Actually, almost I properly reached. Now look, if x belong to the element on the left side, I reach x is the element of the right side. Vice versa. If x belong to the right side, then I got x belong to the left side. Okay. So proper proof is done. The last one. How do I prove the here equality also holds? Okay. So for the equality of the holding the proof over there, let me properly explain. Now, I think here nothing wrong and nothing left. So if x belongs to the left side, I prove that x belongs to the left side. If x belongs to the left or right side, then it belongs to the left side. So y says is also correct. So they are equal. Can I remove? I think okay, huh? So everything is proper and correct. So actually, please pay attention. Once you take definition of this, then by applying f of x, you get like this. Then from here, f of x belong to the union. After that, put the x inverse. Okay? So that way we can prove properly. Now I think I will prove this after this the second one also. Okay, now I have an idea how to prove. Okay, now let me show the second part. That x belong, the last one, belong to the f minus 1, A intersection B. Intersection B. Okay. Now I will show you that it is it is belong to the right side and vice versa. So how we start? F like this, then x by first they choose the right side. Huh? Take the element from the right side. Okay, I choose from the left side. Over there also there is. If x belong to the okay AB, then f of x belong to A intersection B. Okay, now what I do? From here, I act f function from both sides. F minus 1 actually it gives the identity operator. So f of x belong to A intersection B. Okay, from here by acting f, I can get this. By definition, f of x belong to A and f of x belong to B. Okay, I got from this by definition that inequality. Okay, so I got it from the left side. So f of x belong to the I took element from the left side and get that now if I act again f minus 1 to this equation. So f of x, x belong to f minus 1 of a, and x belong f minus 1 of b. By acting inverse, I can get this. So x belong to the f minus 1a and f minus 1b. From here, I can say x belong f minus 1a intersection f minus 1b. Okay? So I have shown that if I take element from the left side, then it is the element of the right side. You see? X belong to f minus 1, x belong to f minus 1a and f minus 1. Proper, right? Proper. Next, the second, I will take, this is the first part. Now, second part, I will take x from the right side, f minus 1 of a intersection f minus 1 b. By definition, this means x belong to f minus 1 of a and x belong to f minus 1 of b. And by acting f both sides, I can get f of x belong to a and f of x belong to the b. From here, if f of x belong to a and b, then f of x belong to the a intersection b. Intersection b. If I act f minus 1 both sides of this equation, so I will get x belong to f of minus 1 a union b. Look, if I take any element from this, I reach, it is the element of x. Okay, I think this is very proper proof. Nothing wrong and everything is in the proper order. Could you get idea? So I get equality. Now I will prove this. Now because of this, proof, I got already the idea. I hope I can prove now why this one doesn't equal. Theoretically, I can prove it. So I will take element from right side. So I am proving the second one. Okay, this one. So I'm taking element. You see from here, what is this? F of a and f of b. So actually, I am taking element from f of a intersection f of b. Okay, I'm taking element from here. By definition, this is y belong, actually instead of y, I can put f, right? F of x, because after that we act the element. The f of x belong to, actually I'm taking the element here, element of x, element of y. Correct. F of x is f of a, and f of x, and here n, n belong to f of b. So if I act inverse of the first equation, then I will get x belong to a and x belong to b. From here, x belong to a intersection b. Okay, intersection b. So yeah, not here you know here element of y and here element of x. No, I cannot do like this. Okay. So if I take element here, then the f of a is the element of y. Yes, y belong to this. Currently, so in that case, I just put as y. Okay, so I am trying to so y belong to a, y belong to f of. So if I take f minus 1 y from here, it belongs to element of a, or and f minus 1 y is the element of b, is the element of b. Okay, so f minus 1 y, actually f minus 1 y is the element of x. Yes, is the element of x, but I want to show y actually not belong to this. Here I cannot apply this technique. You know, here the inverse technique works very well, but here it doesn't work because I want to show that element of this, not element of that. Okay, so this one still problematic actually. I said I can easily get like this, but because inverse and f has different properties, so that's why I can't get direct proof. Okay, let me think. Still I cannot prove properly as we done here. Anyway, so now it is almost what time is it? What time?
10:53, doctor.
Oh, almost finishing. Okay. Now I summarize. I do summarize. Okay, I hope now here, you know, when we prove when y is here, by definition, x was there. Actually here, we should use a definition first, not you see. By definition, x belong to this. Then it is like this. When y belong to the f of a or f of b means f of a and conversely, when y belong to this, then y belong f of a or f of b. Okay, definition actually this one actually proof of the first one. That's why yeah, everything is okay. By definition, we can get we reach the solution. But unfortunately, for the second one, we cannot get the inverse. That's the problem. Okay, if I find next time, I will invert. So all this one now, you will prove the rest of the problems you will prove. Now, this definition is also very simple, and I hope you can finish your class. 4 o'clock? You have class 12 o'clock?
For me, I don't have, doctor.
So now, please, this part also you read it and try to understand it. So tomorrow we have class. I will explain what does it mean injective function. bijective function. Okay, so good definition and theorems we will prove tomorrow. And here there is example. Please read it. All this one is in your hand. And now the new lecturer came here to continue. So you see, what does it mean injective? What does it mean bijective? Actually, today we have the technique how to deal with the inverse function acting to the, not just x, inverse function acting of the f of a. You see, if f of x, usually we get x, but then we have a, also we can get a, and minus c also get the c. So anyway, this one tomorrow we will prove, okay? And I hope we can reach until equivalent sets. And this second part is actually a little bit hard. You see, everything is needed to prove, and this is we call it composition of two functions. Previously, we have only one function. Now, if we have composition functions, how can we prove that composition of f and g, actually here we read composition of f and g. Yeah, composition of g and f, they are not equal. Okay, very interesting problem, and I will find some more examples here. Actually, example is not much, only few examples are given, mostly the theorems, proofs, corollaries, and so on. So I hope with this one I can finish, and tomorrow we will continue and pass. Please revise, okay? And now since I am teaching here, next class will be another class. Please, if you are in UMT, please come to the class, and please don't disturb us after 15 minutes. Okay, up to 15, okay. After that, I don't care, because it takes time, to every time allowing. Okay, thank you. That's all for today enough, and I'm going to finish. If you have any questions, you are welcome. And today I can see, the few students didn't attend. Tell them this is not easy subject, and if you are not attending, then next classes will be blue. You cannot understand. There is a chain, very strong chain. Okay, that's all. The recording is there. I will send to you, and see finishing. Thank you very much. If no questions, see you tomorrow.
Doctor, attendance.
Oh, attendance already in here. I will use, otherwise, can I use my memo? Actually, thank you, but I put, yes, my memo. I should use my memo. Okay, one moment. Now, actually, you should do this. Boy, I keluar get now it, morning cannot strange this. To be sure. Please, you do the QR codes and subject. Oops. Okay. So now I can share again, and you can sign and finish. Can you sign the register and finish? Thank you. Already 11 o'clock. Now you lecture are here. After registering, you can leave. Okay. I will just-
Doctor, I have another question
yes, welcome.
regarding the quiz the other day because I couldn't attend due to
Yes.
some emergency.
Okay. I need to construct the new questions for you. Similarly, tomorrow I will tell you the timing. Okay, today I make it, and tomorrow actually we have class from 12 to 1, right?
Yes, doctor.
From 1 to 2. Are you okay?
Yes, doctor. I'm okay.
Okay, that is tomorrow after our class. Okay, today I construct, and tomorrow I will give chance.
Okay, doctor. Thank you, doctor.
Okay, thank you. Thank you. So that's all. That case you can out. Let me off